A very good afternoon to all of you, all the participants who are attending this particular course. So today we have come to the second last lecture in this course, that is on crowdsourcing and participatory GIS using online tools and technologies. Apart from this, I will also be covering a small overview on geofencing. So to begin with, the content of this particular session is I will be talking about the overview of crowdsourcing, what is the architecture that need to be followed for this particular approach, some examples, some ISRO case studies, and one application development demo also. See how you can build up your own crowdsourcing based solution so that you can ask from the users to collect the data for you, and that data you can further analyze for various decision making processes. So if we talk what is crowdsourcing and participatory GIS, they many times these two terms are used interchangeably. People also call it a crowdsourcing, participatory GIS. Basically, crowdsourcing is a generic term. It is not specific to GIS. We have a lot many of applications where the data is collected from the crowd. Now, if we take the data in the GIS format, then it becomes geospatial crowdsourcing data collection. Okay, so if we talk about the definition of the crowdsourcing, it is an online distributed problem solving and production model. Here the crowd they typically form an online community based on the website, and the crowd submit solutions to the site or produce its content. And many times we also call these individuals as a sensor. So sometimes if we talk like crowd as a sensor, they are acting as a sensor for data collection. Although we are getting a huge amount of data from different kinds of ground sensor, but for us, people can also act as a sensor. They in whichever location they are. So at the current data set or the information from that particular place, they can send it to the central server. One example is a very typical example in which you find the traffic data in your mobile phone. Whenever you are traveling from one place to another, you just search what is the shortest route. Apart from giving the shortest route, it also gives you what the condition of the traffic over there, how it is giving that traffic condition, whether they have installed sensors over there in all the roads. No, it is not like. The typical example is from the crowd. Their mobile phones are there. The crowd which is moving on that road, they have their mobile phones in their pocket, and most of the time, say the data or the mobile data internet connectivity is very easily available, and it is very cheap also this time. So it is directly available on the mobile phones, and most of the time people are keeping their mobile data on also. And whenever they are moving on a traffic, if the speed increases, the movement of those citizens or the people on road increases. So it says there is a less traffic. If it reduces down, it directly we can induce that there is a heavy traffic. So this particular information, this speed information, is directly fed to the Google server over there. And from that Google server, it is giving you based upon a large number of data sets from all those people who are traveling on that road. You get the condition of the traffic from there also. This is one example. So here the citizens are working as a sensor. You see in this one example here on the road, one photograph we have seen over here. See how the different kinds of accidents or these traffic jams or the road hazards, they can be directly linked with information collection from the crowd. The crowd sometimes directly we can give the mobile app to the people, and they are sending the data to us. Otherwise, implicitly also we can get the data from their mobile phones as well for better decision making. So now the crowdsourcing of geographic information, it addresses the following point basically. we are talking about the crowdsourcing of the geographic information. The collection of geospatial data contributed by non-expert user. Important point is here, the users are not an expert GIS user. They are non-expert users. So from there we are getting the data sets. And the aggregation of these data into meaningful geospatial data sets. So once the data which has come from a non-expert, what I am doing, we are now aggregating these non-expert data into a meaningful GIS data set. Okay, so aggregation is an important keyword over here. The data is coming from the non-experts. They are not the experts of GIS, but still they are able to send some data either implicitly or explicitly. And then we are aggregating that data so that it can convert to a meaningful geospatial data set. Okay, so there are numerous definitions of crowdsourcing. A few characteristics, they include outsourced to the human workers, online and distributed, open call, right incentive. I will be talking about these points also over there, diversity and independent. And it follows both the top-down as well as bottom-down approach. We are also giving to the crowd and something we are taking from the crowd also. So it is the crowdsourcing, basically it is not a very new term. Before the web, before this mobile phones or the internet, it was existing there at that time also. So there was a very famous project by the name called GLAM. Galleries, libraries, archives and museums. They used to collect all the historical data from there, from the crowd itself. In the 19th century, a natural history collection. This is again one very good example of a crowdsourcing based before the web. The 1849 Smithsonian Meteorological Observation Project. This is another project which uses the concepts of crowdsourcing. So the data coming from the crowd. 1857, 1878 Oxford English Dictionary. For World War II soldiers, given a field collector manual in natural history by the US Museum of Natural History, James Murray, and you can get the detail of those things. So it is not a very new concept. Since ages, people are using this concept of crowdsourcing. But over the period of time, technology has given a new dimensions to this, this particular approach. So if you see the very path-breaking revolution came with the introduction of Web 2.0. Web 1.0 was a static web, whereas Web 2.0 became an interactive web, wherein the content from the users was also incorporated in the web environment. People were also able to contribute to the data. They were able to in Web 1.0 we were having the data one-sided only. One agency is there, they having some information with them, and this information they are disseminating to the n number of people to the world. Now, in order to get the data from these people back into my server in some mechanism, so that is called as a user generated content, UGC. Basically, that came up with the invent of this Web 2.0. So that was not the only concept over there. There were many other aspects also that were integrated into Web 2.0. The web became as a platform for the data generation, participation from the people, content syndication. This is very important point over here. Content syndication means, suppose I have the data, I have the information in different kinds of websites. There is one website for the forestry, there is one website for the weather, there is one website for, let us say, the soil related information. Different websites are there, different agencies are there which are producing some information on their website. Now, suppose I want to create one decision making website wherein I need the information from all these websites. So this content syndication, it allows you to fetch the data from these different web platforms or different websites and syndicate them together for your decision making. So that is all possible. How they are all possible? They are possible with the help of these concepts of APIs, application programming interfaces, or the web services. So this is the conceptual aspect to that Web 2.0 and how they are implemented. What are the technologies behind it? So there are technologies like XML, RSS. This is the really simple syndication. XML means extendable markup language. This is one data import, data exchange language over the web. JavaScript is there, Ajax is there, and more recently, new technologies are also coming up, which are enhancing the concept of crowdsourcing in the web environment. Now, if we see the GeoWeb, the Geo part of Web 0.20, it basically, we can say, merging of the location data or the spatial data, geographical information with the abstract information of the traditional websites. There is some information is there in the website, and we are merging not the location. We can say we are adding a geotagging of those information which are available in traditional websites. So that way it is coming up. So huge amount of data is available in that. Google Map API is very popular. One example which works on this concept. So this let us take one example of geotagging over here on the Flickr photo sharing service. This is one photo sharing service again on the concept of on the crowdsourcing. The users have geotagged more than 25 million pictures over there, providing location data that allowed them to be viewed on a map through 3D visualization software like Google Earth. There also we can say it. Similarly, Placial.com, it has access to more than 30,000, more than 30 million locations. Many are there. So, how it is coming up now? What is the we should talk what are the technology behind it? So the mobile or the wireless technology is the core concept which is enabling the crowdsourcing approach, wherein without much of the training, people are able to contribute the data for decision making. If you see it here, the advantages of mobile, it is smaller in size, you can easily carry it, it's faster, location aware, all those most of the time in a smartphone, a GPS chip is mostly it is available in most of the phones. So it is location aware, also smarter in the sense it can integrate the data of GPS, your camera or some other sensors. All these information can be geotagged, integrated together, and then can be pushed to the central server. So it talks about the embedded information as well. So if we talk about the spatial crowdsourcing concept, organizing the crowd to do spatial tasks by physically moving to the other location, or we can also talk it like mobile crowdsourcing, mobile crowd sensing, participatory sensing, location-based crowdsourcing. These are some of the very common terms which are used in case of crowdsourcing. So this person, if you see Steve Coast, this one very good example of the spatial crowdsourcing is your OpenStreetMap, which was launched in the year 2004. It was collecting the data from GPS devices, editing from the users was allowed over there, and answers from the queries also. So if you see it, the huge repository of the data has till now it has been created in this OpenStreetMap, and the people can download this data set, they can contribute to this data set, they can edit the spatial entities available on that map. So that kind of resources are available now. All it has been possible through this Web 2.0 with the publicity of this one Web 2.0. Now, if we talk about the classification of the data obtained from the user, so there are basically two types of data that we get from the user in a crowdsourcing environment. One is the explicit information for which your application has been designed, desired thing. Some information that is called the implicit information, they are the derived information. It has been like, let us say, the roads in the OpenStreetMap. So they are the explicit. It has been designed to contribute road information in that particular platform. Whereas from the GPS track, we can derive the road information. I have a continuous GPS track. From that, I can say what is the spatial data for the road from this GPS track can be derived. It can be implicitly we will get the data from there. So there is only one data, not only one desired data, but also a derived data that comes to us in the form of for these various kinds of information dissemination, data dissemination. Now, if we talk about the comparison between the crowdsourcing or the spatial crowdsourcing, if you see the Wikipedia, this is your very important crowdsourcing platform, a web platform we can say, where a huge wealth of information is available. And in the similar term, OpenStreetMap is for the spatial crowdsourcing. Similarly, passive participation, real-time traffic through this particular platform we are getting, and this is like labeling the images specialized platform. Uber is for the spatial crowdsourcing. We can say this is the crowdsourcing and this is the spatial crowdsourcing for it. Similarly, general purpose platform, Amazon is there, or Gigwalk, location specific job finder. So these are some of the examples. For whatever crowdsourcing, we have an alternate spatial crowdsourcing application currently available in the web platform. But if we talk about the core issues in spatial crowdsourcing, we have the quality control, the task assignment, incentive mechanism. These are the three core issues of spatial crowdsourcing. Quality control, here the crowd might commit some errors. The errors can be spatio-temporal factors, might influence the quality. Let us say one information is provided through a crowd, and that data is having some wrong time stamping. So at that time, these kinds of control quality issues can occur while using this data set for some kinds of decision making. Similarly, incentive mechanism, recruitment or payment of the mobile crowd workers is not free. Sometimes the people are voluntarily providing the data set to you, but the other time we can also put some incentive mechanisms where we can give some promotional or some advertisement kind of approach for the crowd who is collecting the data for you. So, like one example, if I give you here, so one project we have executed for the Planning Commission in 2013. So at that time, a huge amount of data was required to be collected for the disaster that occurred in the Kedarnath area. So at that time, the students living over there, so a small incentive in the form of a small mobile phone was given to all the crowd, and they were able to collect the data, and happily they took that mobile phone and they collected the data for us. So that became an incentive for them, and we were getting the data. In 1 month we got around more than 16,000 points were collected from them. Okay, so both the things are there, pros and cons are there. One thing you are giving to that, but in return you are also getting some information or the data from the crowd. Task assignment, who is to whom the task need to be assigned. It is a not very simple task. So who will get the data for you? There can be some people who will be readily willing to get the data, but they are not expert in that domain of data collection. So this again becomes one small issue in case of the spatial crowdsourcing. So if we talk about here the spatial crowdsourcing system, how it works. So the tasks are assigned to the different users, and there is one spatial crowdsourcing executor. Task is assigned to the user. There is a quality control and incentive mechanism is in place for that. Okay. Once these are in place, then the crowd-powered spatial operator, SC path selection, speed estimation, SCI point of interest labeling. So these are done at the middle level. Once it is done, then this data goes into a database, and then again it becomes to the a property of the requester who is collecting these kinds of data sets. Now there he can perform indexing, optimization of the data for making it used for some meaningful geospatial data sets. So in the participatory project model, basically we have there are three concepts into it. First is the contributory, second we call it as a collaborative, and co-creative. So the contributory, the public contribute the data to the project designed by the organization. It is a contributory scheme, we can say. Collaborative means it is both are the active partner, both the organization as well as the users. They work together for the data collection part here. So co-creative, all partners define the goal together. So the goals are defined by both the data collector as well as by the stakeholders who are collecting the data set. Now, if we see here the concepts of participatory GIS in similar lines, so it is a approach to spatial planning and spatial information and communication management. If you can see here, so one decision map is created and we have the local people who are providing their viewpoint on those decision maps. So we are taking their a complete holistic participatory approach for any kind of decision making over here. Similar is at this point also, while doing any kind of planning, the inputs from the people are also taken, the end user, the people who will be using it, that input from them is also taken, and then only necessary actions are taken. So the fundamental challenge, what are the challenge core issues I have talked. Now talking about the fundamental challenges. So there is a challenge of a quality always, because the data is coming from the crowd. So it is not like always the data will be of good quality. It can come of some poor quality data sets also. Task assignment, already I told you. Incentive mechanism also I told you, but how to control all these challenges. So that again becomes one issue. So one of the solution for improving the noise from the data or improving the quality of the data is majority voting, or it can also be a Bayesian voting. So what we do in the majority voting, we take the answer that is aggregated by the majority, most of the people, because the data is coming in huge amount. So we take the data which has come from majority of the people. So that can be taken as a good data set. So that it is not like I will take all the data sets. You just take that for any one particular aspect. Suppose 100 people are answering the question to it, or they are putting the data for that, and out of those 100, around 70 people are saying the same thing, whereas the remaining 30 people are saying some different things. So we will be taking the data of these 70 people as a aggregated data set. So similarly, the concept of the Bayesian voting, here we take the probability into consideration for improving the quality of the data sets. So if you see it here, the traditional workers only need to complete the task on the internet, wherein this spatial crowdsourcing, workers physically move to the location of the task here. In this, so the aggregation method which I was talking earlier is also applied to the quality control in spatial crowdsourcing, but with spatio-temporal constraint. So this is a very important concept over here, aggregation for the spatial data set for the crowdsourcing with spatio-temporal. Spatial means where it exists, temporal means at what time it occurred. So not only the location is specific, but the time also matters for it. So these two components are also taken into consideration while doing the aggregation of the data set. So the difference is diversifies the answer. It may yield good quality of the spatial crowdsourcing based data sets. So typical features of crowdsourced data, if we talk, it is high in volume, whereas the quality is coarser. Because the data is coming in a very high volume, so there are chances that it may have some noise embedded into it. So the precision or the accuracy of the data, it becomes a little bit coarser. Challenges: motivating the crowd and ease of data collection. These are the two important aspects of crowdsourcing data sets, wherein they are how to motivate the crowd for the data collection and how to make the process easier. So I will be giving you one small demo where we have tried to make this entire crowdsourcing data collection process in a very easy step, that how the crowd will be able to collect the data for you. So this is a typical architecture of the crowdsourcing data collection. So it basically consists of a mobile device. It is a location information that comes from the constellation of GPS. Wireless connectivity is required, or the mobile connectivity, or we also require one GIS app, one small mobile GIS app, and web GIS server is also required in case you want to display some maps as a background image, as a base map in the crowdsourced data, so that a user have a better understanding of the spatial of the spatial features which are available on the field. So some GIS data set, and there is a multimedia option also, like photographs or some other sensors, they can also be integrated into it. So here the center of the architecture is the mobile phone. It has one GPS chip which fetches the location information from this constellation of satellite. It also has some sensors like a camera, you can say. It fetches the photograph or the multimedia information from there, and it also has a small mobile GIS app which interacts with the server while fetching the base maps from there and then sending that information collected in the field back to the server. Okay, so this small demo we will also try to understand, where we can have it here. Some examples of crowdsourcing data includes, we can say open. I already told you about the OpenStreetMap. You just here a wealth of vector data basically is available here for usage. You can download it, you can edit it, you can then further add your data sets also over there. So similarly, we have Wikimapia is another project. It combines the interactive web map with geographically referenced wiki system. So that textual information which is available on the Wikipedia, that also get in sync with this particular platform, Wikimapia. Another one is the Google Maps here. Okay, so this Google Map is also available as a crowdsourced data where people are contributing their data and they are able to get a wealth of information in this particular platform. Key application area of crowdsourcing data, where the people are using it basically. For mapping, we can use it. Different kinds of mapping can be done. Like we can say asset mapping. You want to do a mapping of all the natural resources available in a particular area, or the tree species mapping you want to do. Let us take one simpler example. You want to do the mapping of the ATM locations in a city or the tree species in a forest. So you can hire the people who are living in the vicinity over there. You can supply them your mobile phone, and they will whenever they will visit any particular mobile ATM location, or a forester, in case of a forestry people visits a forest area, so at that time they can tag, or they can collect the information related to that tree or the ATMs, and then it can be mapped for a large number of from the large number of users. Understanding the urban forms and functions, traffic assessment, already I told you. Geotagging of asset, this can also be performed. Damage assessment can be performed with the help of a crowdsourcing data. 3D scene reconstruction, this is one very classical example wherein you can create a 3D image also from the crowdsourced data set. There are many more applications which can be performed with the help of crowdsourced data set. Some examples, if you take it here, apart from those online applications, this mobile applications also, there is one very good project called iNaturalist. It is basically an app, mobile app, which enables the identification of species from different kingdoms. So this is one crowdsourcing based project has been initiated by the Academy of Science and Natural Geographic Society in California. So this is readily available. So here around 302,000 species have been observed, and people who have signed it, a large amount of people have signed up for this particular project, and till date a huge amount of data set, if you can see it here, 52,883,295 data have been collected. So it ensures that now this particular project, it ensures that the data is reliable it also gives opportunity for fellow users to gain knowledge about species from around the world. So the flow is like that: record your observations, share with the fellow naturalist, and discuss your findings. So the concept goes like this. It is directly available free of cost in the Android as well as the iOS, and it is also accessible as a web page as well. The link are given over here. Similarly, Planet, this is another project for the plants, basically, dedicated solely to the plant. The previous one, iNaturalist, was for the different kinds of species. It can be a plant species, it can be an organism, microorganisms, it can be any other living things. It can be from the not only from the animal kingdom but also from the plant kingdom, both the things. But here, Planet is solely for the planet. Pattern recognition, automatic plant species recognition, entries are being validated through the collaborative tools, identify Plantae and Pictoflora by Tela Botanica Association members. So it actually it is also available as a mobile app for iOS and Android, and it also has a desktop-based application by the name planet.org. eBird specifically dedicated for the bird-related species. So here you can get a wealth of, it has not only a web page but also a mobile app. You can download it from the Play Store. It gives you to capture the bird information, share it with the other fellow people, and you can also take the data which they have collected from around the world through a website. So that is also very much available. Some examples of crowdsource-based project from ISRO. So there was one, I already told you, Map the Neighborhood in Uttarakhand. This was the Manu project during the time of disaster in 2013. So this crowdsourcing-based approach was used for collecting the data from the affected area to assess the impact of those disaster at that time. It was maybe a damage to the building, it can be a river bank erosion, damage to the natural land cover, natural resources, and landslides. So the data on all these aspects was collected in a crowdsourcing, through a crowdsourcing based approach. And you can see once the data, around a huge amount of data set was collected, this platform is available still in the Bhuvan Geo portal. There you can visualize these data sets, and we were able to do some sorts of analysis on top of it, identifying what were the causes that led to that huge disaster and what further hazard it poses for the particular area. So if you see it here, this was one small example here, analysis example from that crowdsourcing data. This is the flooding, around 28%. The processes responsible for the damage from that data set which we were able to analyze. Flooding was the most influential in that part, and landslides were there, and subsidence, bank river erosion. So small, these kinds of analysis can be performed with that data set. Okay, now there are some popular mobile mapping applications which are working on this concept of crowdsourcing. We have the collector from ArcGIS. This is a proprietary in nature. It is free to use, but it requires an institutional account. It is both Android, iOS, Windows, and it also have online ArcGIS and ArcGIS server support for the data collection. Similarly, Mapit, it requires an yearly subscription. Again, it is you have to pay for it. This is the Q field from the QGIS. If you are aware of that QGIS software, so this Q field is a QGIS compliant. It is free to use and modify. But the one thing is that there is no dedicated online platform for data sharing over here. It has a good external GNSS receiver support, third-party application, and Open Data Kit. This is a complete suite basically. So we will be working on this Open Data Suite for the crowdsourcing app, for the demo of the crowdsourcing based approach. So it has been released under Apache 2.0 license. It is basically an Android based application which allows you to collect the data, analyze the data, design the data as well for collection. and it is free to use. You can easily modify it, and it also fits well with Google Drive. There are some other application also like SW Map, Locus GIS, Global Mapper, mobile data collection. They all have their own limitations. Some are free to use and some are they require some yearly subscriptions also for access data if you want the extensive features from that particular application. So let us take one small demo of this Open Data Kit, how it works. So for that, what we will be doing, I will be having one. So it works like this. You can say here we have one. We can say for the crowdsourcing based approach, one manager we have who designs the form for you, okay, for the data collection. So we will follow this particular approach. There is one thing called manager who will design the form, and then I have the crowd who will collect the data. Crowd, we can say. So this is the crowd who will collect the data. Manager, he will design data collection form. Data collection form. Okay, he will design the data collection form, and can bring it at the top here. See, the data collection form will be designed by the manager. After that, the crowd, the people, they will collect the data for you. See it here, collect the data for you. Data collection, you can say crowd is for the basically for the data collection. They will collect the data for you. Say it here like crowd hai, it will collect the data for you. Project data collection, data COLE collection, and then third we have the analyst who will analyze the data sets. He is the analyst or the decision maker, or the you can say analyst, LYST. He will analyst, he will data analyzer, data ANALYSER, or we can say data manager, data analyzer, or decision makers also, or we can say analyzing the data analyzer. Okay, so how this will work now? So I told you we have the concept called ODK we will be using for this particular implementation. So see here we have this complete ODK set which will allow us. Now what happens over here, if you see, the manager, he designs the form. Once the form is designed, then he hosts that form in a server. Design the form that is hosted on a server. What happens next is the crowd, they will download this form from the server, and once they will collect the data, they can again submit the data to the server. So they are downloading the data set from the server, the blank template. So here I can say we have the template. Template is there. This data template, data TMPLA data template is there, and then once data template is created, then it will be uploaded from the manager at the server end. Upload data template, and then here this particular user, they will download that template in their phone. Download the data template in phone, mobile phone, the mobile phone. Okay, and then once it is downloaded, so they will collect the data, and once the data is collected, that data is then again fetched to the central server here. Now here we can say it is the crowd has two tasks to do. It is upload data upload data, upload collected data. Upload collected data. So data will be uploaded to the server. Once the data is uploaded to the server, then it becomes the task of the analyzer to analyze the data and do necessary decision making or any other task associated with that data set. So here we can say he can download it, he can analyze the data sets here. So this is the complete workflow which we will try to understand now. Data upload here, you can say data visualization. Data visualization and analysis. LYSIS. He can also download the data set from this particular place. So this is the complete workflow. Now, how this is implemented using some technology, we have to understand that part. So for that we have ODK here. So the first component will be the manager's component. So this manager's component, for that we have one module in the ODK that is called ODK build. So build. Okay. So how it is done? ODK build, it is an online platform which allows you to create, design the data collection form. So let us do that part also here. If I say, you can just type it here, ODK build, ODK build. So just click the first link over there. Once you have clicked it, it will load the dashboard for you. Here you can create your own user. Since I have my own users, I will just log in with that my user credentials. So you can see it here. You can create new user also, or you can sign in with directly. So once this comes over here, now let us do one household survey form data collection. HOUSE, household. We can rename it. Let us say household survey. Household survey 2022. Some name I have given to it. Okay. So or species household survey we can say done. Now we will add some queries to it. So how to do that one? The text part, first question, I want who has collected the data. Name. Okay, name, type, because the we can type. We cannot say the type the name. Let us take some queries for that for this particular here, because the name of the observer we can take it from the mobile phone also. Direct, there is a one-time effort. Again, for every data collection, we need not to take the name of the surveyor, because that will automatically come with the mobile phone. So here we can say name of the street name, wherever he is, street name. So type the name of street. Type the name of street. This will be the first question. He will be filling up that part. We can do it here. Required length also we can set for it. Second, let us say second numeric question we want number of people. Number. Please don't leave any spaces over here. Number of people. Here you can ask the question, how many people are staying in the, how many people are staying in the house? Okay, and this is again a numeric value. Then third, we can have how many floors that building is having. So that again we can take choose one. So choose one means any one he will type it. Number of floors, number of FLOORS, number of floors. Here we can say select the number of floors. Number of floors in the building. We can do one small example. Options here. Now here we can say first option is single story, or this under there we can type it here like this, single, and then value will be SINGLE, single. Add one more option that we can say double. Then we can have here some value also for it, double. One more option we can add. multi-story, only this multi STORY. We want like this only multi-story, and here also we can say LTIS, more than three. We can more than two. We can say more than two, more than two. Then here we can have also the value more than 2. Okay, so let us take only three questions. Then we can also take the location information because we are interested in the spatial crowdsourcing. So location also we can take. So here LOC location. Here we can say capture. What it will do now? It will interact with the GPS of the mobile of your mobile phone and capture the location indirectly over there in the phone. I will show the demo also. Capture the location, capture the location, LOCAT, location of building. Okay, it will, the question will be posed, capture the location of the building, and this is also required field we can say. And now here we can have a field, point, path or shape, anything we can have, and we can also default show some map on the background. Let us say show map also. Okay, point, and it will show some maps as well. So three questions are there. We require some multimedia information also. So multimedia, we can take photograph of the house, capture the photo of house, capture the photo of the house. Okay, so this is also done. This is again required. We can have a photograph, image, drawing also, video, audio, anything we can have. So I am taking one image section over here, and then we can also take date and time as well. We can capture the date and time as well. Let us. I will stop here. I will take these many questions only. Now you just save it here. File, save form. The form is saved. Now let us save. Now if you see it here, the second, this particular portion is done. ODK build has allowed you to create, design the data collection form from the ground. Okay, now this data, this design template need to be uploaded to a server. Now this server you can establish at your home also, but we can also take facility of the Google Drive as well. Okay, so what I will do, I will try to upload the data in my Google Drive and this particular template, and from there this crowd will be able to download the template, and they will also be able to fill the data and send it to my Google Drive itself. So now this component, this server, let us try to set up this server. So you can see here how to set up the server. I will go again back to the Google Drive over here. If you see it here, Drive. So in the, I have already logged in there. So I will create one new folder. Let us take a new folder. I will create it here. This is GNSS LBS course 2022. Some name I have given to it. Create. So once that folder is created, okay, now inside this folder, I can create one submission file here. Now if you see it here, the crowd, they have to collect the data and then send it to the server. In server, that data will be residing in the form of an Excel sheet here. We can see here Google Sheet. You can create one blank Google Sheet here. You can give some name to it here. HOUS, Household Survey 2022. You can give it here. So it is saved to the drive now. Okay. Now you can share it. Share. Now copy the, we can say, we can change, click on this particular option here and change the type editor. Okay, from viewer you make it an editor, and you can copy the link and done. Okay, so once you have copied that link, now you come back to your ODK build here. If you see it here in the option view, we have in the option edit, we have form properties. Now there is one option called submit URL, submission URL. Just paste that copied location of the Excel sheet over here and save it. Done. So whatever data is collected by this form, it will go as a particular row in this particular sheet. Okay. So now what we will do, file, you have to download it, save the form, It is saved and then export to XML form. This is one popular, I told you earlier also in the initial slide that XML is an external markup language which is used for the data exchange format from mobile to the website, from website to mobile, or from one website to another website. So this XML is used basically. So download it. So once it is downloaded, now I have to do what I have to do. I have to, this design is downloaded. Now this design you have to upload in that Google Drive. Okay. So it is done. I will just copy, so in the folder here, and this was your Google Drive here. Okay. This thing. So now what we will do, we will try to put this XML which we have downloaded just now, the XML file, let us try to upload it here, household survey, and it is uploaded here. Directly drag it here, so it will be downloaded, uploaded over here, right click to it here, and then you can do the share. Okay, and share, so here I can write the email address of different people and they can take it from there also. Otherwise, what I will do, I will and change to anyone with this link. Okay, so click it here, you make it as a editor again here, and then done, and you have to share it. Actually, you have to share it, you have to copy that link basically. Copy this link. If link is copied, now if I give this link to anyone, then they can use this particular form in their mobile phone also. How they will do it, I will discuss that also. But before that, I am just sharing this link in your chat box over here, so that if you can try it out with your Google Drive, you try to upload this thing over there. Okay, so this I have. I will do what I will do. If possible, I will share this link with you also. So just a demo purpose. In my slides, I will try to add it here, and then this will be available to you as a study material also in the e-class platform. Okay. So this link I have kept it over here. Now using this link, you can also use the same design template. You are the crowd now for me. Now you can use this link, and it is already in the server. Design is up there. Now the crowd component, this crowd component, they have to basically collect the data set. How they will collect it with that design. So for that, I will show you one small demo here. I will, the mobile phone, how it will come. If you see here, for this particular place, we have used as a server, what we are using, Control C here, then Control V over here. So here we have as a server component, we are using Google Drive. Okay, Google Google Drive. All right, Google Drive. Okay, this is done. So here the server is this Google Drive is acting as a server for me. I have uploaded the template over here. Now comes the component of the crowd. How they will get this template in their phone. So that is also simple. Sir, I will try to tell you how you can download. There is another component called ODK Collect. Okay, so that you need to download from Google Play Store. Here ODK Collect. So ODK build, here it is, ULLEC, ODK Collect. So this component you have to download in your mobile phone. So I will try to see it here, how it is done. My mobile, I will show you here. If you see it here, okay. This one phone is coming over here. So we will try to, now you can just see my mobile phone. It is visible to you here. So here already I have installed ODK Collect. So I will try to remove it from here. Or you can go to directly to the Play Store. My Play Store. If you see it here, go to the Play Store. In the Play Store, you can type at the top ODK Collect. Okay, so once this ODK Collect is there, you just install it I will try to open it here. It is already installed there. It is done. Then you click on this icon over there at the top. This one here, you can change the settings here. Server name, you can type here, select the type. There are two options, ODK and Google Drive. Since we have kept the data in Google Drive, so I will select this Google Drive. It is already selected. Google account, then you can take your Google account also. My Google account is this one. Okay, selected this part also. Come back and then you can come totally back here. Now we want to, so the setting is done. So it will ask for some initial username also. At that time you can give some domain name also, like irs.gov.in. I have written it over here. You can create your own. This is a dummy name over here, which will, this is not a live URL, which you can create your own URL also, that can be supplied at that time. So once it is done, your server setting already done. Okay. Now what you have to do, you have to fetch the form from the cloud. Google Drive I have already given, get blank form. So if you click on this get blank form, it will show you the option called shared with me, the crowd. Okay, whichever form is shared with me, you click on this shared with me and it will list the forms which are shared with you in the Google Cloud. Okay, so here, since I have only created the form, so it is not directly visible here. So I will go to my drive option here. In my drive option, if you see it here, just now we have created one form. It was like GNSS, LBSS course, household survey. Select this one and download selected. Okay, so once it is download is successful, now your form is in your mobile phone. This is my mobile phone. The form is lying over here. Now if I say fill blank form, if you say household survey, select it and name of the street, like let us say Kalidas Road. Kalidas Road. I will select it here. Next, how many people are staying in there? 100, let us say. Next, it is a more than 2. It is an institutional building basically. Next, start GeoPoint. Click on this particular point. Now it will show you the map as well here. If you see here, and it is showing your current location also here. Okay, you can zoom it here. You can just check whether it has come to the correct position or not. So if you see it here, it is Indian Institute of Remote Sensing only here. Okay, so capture it. Save. So you see it here, the latitude, longitude information. It has interacted with the GPS and it has captured this latitude, longitude information. Go to the next here. Take a picture. One small photograph you can take of the building. I have taken one small photograph. So select this photograph of the building here. And with this, my next question is done. Save and form. The form is saved in your mobile. Okay. Next is, now you want to send this form to the server, to the Google Drive itself. If you see it here, this was my household survey. And here I am able to see the mobile phone. Okay. Now here I will say send finalized form, or you can edit that form also. Send household survey, click it here, send selected. So you will see it will, from my mobile phone, it will send the data to this particular sheet. Once it is done, the data is available here. Now you see here, it has started coming to the Google Drive here. Similarly, if you try, you can also send it. So yes, household survey successful, mobile phone is done. The work of the crowd is done. Now you see the data is coming over here. Okay, so then that data which I had collected, like 100 people are doing more than 2, and this was a photograph that we have taken. So this crowdsourcing data is now, once it is done, next is I want to map it. I want to do some analysis out of it. So you have options for that also in Google Drive. My map, just type my map and you will say Google provides you the my map also. Get started here and then create new map. You can create a new map out of it. So click on this new map. You can give some name to it. I will give it here household survey. Survey 2022. Okay, and then save it, and then import that from where I get the data. Import Google Drive, and then GNSS course. Just we have taken household survey. Select. So it will fetch LOC and say latitude and longitude information. Continue. I want the number of people staying over there. Finish. So if you see it here, it will plot that data in this map. Yes, it has plotted this map. Click it here and it will show you all the information. Kalidas Road, more than 2, some photographs also. If you click the photograph, it will show you the photo also of which was captured by the crowd. Okay, so this is the map over here. I think this is, and now there are different types of maps also. Base map here. This all are crowd. This all the information you are seeing over here. They have been collected from the Google by the crowdsourcing based approach. You can have a base map as a satellite image also. So this map was created by you. Similarly, you can have huge number of data set. All the people in the crowd, you can give them the link and they will collect the data for you. So this is very small demo of how the data can be collected through a crowdsourcing. This analyst part also we have done it. We have mapped that data on the satellite images and we are able to see that data set. So this was the small demo of that part. Next, if we talk about the concept of geofencing, this more it will be covered in tomorrow's lecture. But if you see it here, what is this geofencing basically? It is commonly used for the notification when a user enters or leaves a designated area. If you see it here, it is a virtual fencing, a virtual boundary. It can be a rectangular boundary or it can be a circular boundary that can be created based upon the locations only. There is one physical location, then I can create one buffer, you can say, around it, and whenever one person enters this buffer area, his positions, because his mobile is always having a live location, GPS is on, so once he enters that buffer area, one notification is sent to him or some information can be collected from that particular user. So it creates a virtual spatial geographical boundary, and once a user enters that boundary, an event is triggered. Okay, and what is the requirement basically? A mobile app. You need to create one mobile app to be installed in the user mobile so that it will interact with that geofencing. So we can have not only one fencing, but you can see it here, we can have multiple fencing. I can have one fencing for the school related information, for the home also we can have it. We can also track the trucks also, where they are moving, whether they are moving in some danger zone or whether they are in the safe zone, whether they are in the designated path or not. So all these things can be monitored with the help of this the concept of geofencing. So this is a little bit the applications. Some of the applications of geofencing includes marketing, safety, logistics. So these are different applications which are people are using in these areas the concept of geofencing. More it will be covered in tomorrow's lecture also. So this already we have done it. So with this I close this particular session. Then I will take up all the questions. Thank you very much.